It's 5 minutes early, too early? No objections? Okay, cool. I'll start slow, like always. Welcome. Thank you so much for ending your night out drinking early to come into the 9 o'clock session. I'll give you your cue now. Hopefully you didn't record that. Ready? Okay, cool. Hi. Welcome to the first talk, I believe, in the innovation track. There may have been other talks going on. Have there been any other innovation track talks going on? If so, I haven't been able to catch them. Been a little bit busy with my own. They have? Okay. I didn't know if they all started today or what. I do want to make a couple of warnings. If you were in my SignalR talk yesterday, I said 2 things that you're going to learn is really, really true. I can figure out a way to put in SignalR to any demo, even when it's not supported by the target framework that I'm using. SignalR is not supported by .NET MF. I don't care. I figured out a way to use it. Okay, so I'm going to show you a little bit of a SignalR thing today, just a tiny little bit. It's kind of a nuanced piece. The second warning that I want to give you, actually I guess there are 3, is that, like I said in my SignalR talk yesterday, the failure potential during this talk is about 150%. Okay, so I do want to warn you that if you're here because you enjoy Schadenfreude, you've come to the right place. Because some demo or demos will fail today. My computer may blow up, the device may catch on fire, you just never know. All right, third warning. I work in Windows, Azure, and the web. I am absolutely not a microcontroller guy. I just like to play with them. Like any other good geek, I like to find other ways to apply my techno smarts and to tinker and to come up with inventions and all that. All transparency, the way that I got into this stuff is I have a horrible fear of electricity. And a friend of mine told me, he said, if you're scared of electricity and you don't like working with circuits, you should work with like a 5-volt circuit. You should start building robots. And this guy builds robots. Of course he could say that, he's brave. So I started tinkering with it and it kind of got me over my fear of electricity. But you can't get hurt by these things. It's when you get into the bigger ones that you can get hurt. So that's kind of my quick little warning / introduction / welcome to Schadenfreude land for this talk. I just want to make it clear that if you want to see somebody who really, really knows how to do this stuff, go see one of Clint Ruckus's talks. Clint is like our Windows 8, Windows Phone Connect microcontroller wizard. He was telling me last night that he basically wired up a remote control to his home stereo because he didn't like having to use the volume control. So there's that. So I would highly encourage you, if you want to get deeper into this stuff, to go to Clint's talks. What I want to show you here is that the Windows Azure SDK is large. It's a large download. The coding that you have to do with it, you have to use the SDK. If you look at one of these devices, let me show you one real quick. You look at one of these devices, it's got like a meg footprint on it. You're not going to be able to get the Windows Azure SDK on this guy. It's not going to work. All right? So you have to come up with alternate ways of getting to the cloud. Nice thing about Windows Azure is, Scott pointed out yesterday, is that it's really just a whole bunch of REST APIs. So as long as you can connect to the network, as long as you can make REST HTTP calls back and forth to the server, you can do this. So I just want to point that out. It's not as easy this way as it is using the Windows Azure SDKs. Last thing I want to do before I really dive in, this gentleman standing right here with the glasses, give him a round of applause. This presentation wouldn't have been possible without him. Okay? He is the network god. I emailed with an exclamation mark and I said, I need a dozen tech checks because everything can go wrong with this. So he's like, don't worry, I got it. He even talked me into doing a really crazy harebrained demo because he said his network was that good. He was right, because it worked yesterday on the first try. You know what that means? It won't work today. All right, so a little bit about me. As I said, I'm Brady Gaster. I work on the Windows Azure team, specifically the Windows Azure SDK team. So I know how big that download is, and I know about the code because I'm one of the guys responsible for its production. Okay, we basically write the code that sits between your computer and Windows Azure. We make it easy for you by giving you client SDKs. Node, probably heard Glenn talk about that. .NET, my favorite. Java, et cetera, Ruby, the whole nine. So we give you those SDKs to do that stuff. I'm on Twitter. Feel free to tweet me. Feel free to make comments about the talk unless you don't like it. I also have a weblog, showing my age, calling it a weblog instead of a blog. I write about stuff like this, Azure, Windows Azure website, SignalR, API, blah, 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 blah. Feel free to email me if you have any questions. Feel free to email me if you want this presentation. I've already introduced you to my wife, Gina, 2 sons, 2 chihuahuas, 2 guitars, 3 microcontrollers. And the joke is I never have time to play with the guitars because I'm always busy with the other stuff. Okay, so how do you get started with .NET MF programming? Okay, anybody done any .NET MF? I mean like plugged it in and made it work. Anyone? Okay, 1 person, maybe 2. It's a little dark. Here's how you get started. So this is what we're going to talk about. I want to talk about your environment setup, so that's when we're going to get into like how you get started with it. I'm going to show you a real-time temperature and humidity sensor, shooting stuff up to Windows Azure, and a SignalR chart to kind of show you it working. Then we're going to build a security camera with the .NET Gadgeteer. Then I'm going to show you with the Gadgeteer and the Netduino how you can directly access the Windows Azure APIs, specifically the storage APIs. I'm going to show you, anybody heard of the Agent Watch? It's the same guys that made the Netduino. They have a smartwatch coming out. And it's got a .NET SDK that you can use. I think it's even got an iOS and Android SDK, but I like the .NET one. So I'm going to show you some possibilities with that. It's kind of a silly demo, but I just want to show you that you can program against the smartwatch. It's pretty neat. And then I'm going to show you cloud-to-device communication using Windows Azure, and that's the one that my networking buddy was able to talk me into doing. We're going to send messages into this room onto a web server running on the device from Azure. All right, getting started. Don't panic. It's a lot of stuff, okay? Here's my advice. If you want to start playing with the .NET Micro framework, get a machine, flatten it, completely flatten it, and just start over. It's not absolutely necessary that you do that, but all these pieces kind of stack on top of one another. And I've set up a dozen machines to do .NET MF programming. This one is the first one that's ever worked completely 100% because I flattened it for this talk. I installed Windows 8 on it, then I installed Visual Studio 10, 12, and 13. 13 doesn't have any micro support in it yet. That is coming from some of the vendors, but it's just not there yet. Most of the stuff that you're going to see me do, probably all of it is going to be in 2012. When you get to the Netduino stuff, one thing that I want to point out is that the last time I checked, they didn't have templates for Visual Studio 2012, so you have to have Visual Studio 2010. So you go into your 2010, you create a new Netduino project, then whenever you've got it all ready to go, you can close it down and open up in VS 2012 and it'll just work. But you're not going to be able to do File New Project Netduino in 2012. Just want to point that out. It's just sort of a little nuance. Then what I do is I install the .NET MF SDK 1, 2, and 3. If you think you want to do this, take a picture of this. I've given you bit.ly links or AKA links so that you can get to this stuff easily. It's pretty easy to find online. The majority of it is actually at Codeplex. So I've given you links to be able to download all this stuff. Now, I'm going to use 2 devices today. One of those is going to be the Netduino. One of those is going to be the Gadgeteer, and I'll show you the Gadgeteer here in a second. Now, as I'll point out throughout the day, there are a couple of areas of specificity when you're doing .NET MF. You can't do all the lovely wrappers and abstractions and stuff that you're accustomed to doing. You can, but it's really complicated. What you have to do is you have to download the SDK for the specific device that you want to target. So I have installed the Netduino SDK, which is a free download, and I have also installed the Gadgeteer core stuff. That's a little bit of a longer install. There's a couple of reboots involved in it, and it's kind of hard to find. So I've given you links to be able to download all of that stuff. Okay, both of these microcontrollers have been out for 2 to 3 years. They're pretty stable as a microcontroller can be, as you'll find today. And then the other thing that I've installed is the Agent Watch SDK. I only have this handy thing on. I don't have an Agent Watch because they're not done yet. I'll show you the URL for the Agent Watch so you can take a look at it. It's actually a Kickstarter project, one of the most successful Kickstarter projects ever. Now, what I'm going to show you real quick is just a couple of quick links to get you started. First one is going to be a presentation that was done by a friend of mine from the UK. His name is Andy Cross. I organized an event twice last year called Windows Azure Conf, and we had people from the community from all over the world come into Channel 9 and do presentations. A lot of what you're going to see today, some of the code of these demos is directly from Andy's source code that he used in this presentation. He did this really hilarious presentation where he had two Netduinos and an LED strip, and they were fighting it out. Like basically, like one would go green and one would go blue and one would go green, and they would fight it out. And he called it the what's that guy's name? The Sharks with Frickin' Lasers guy, Austin Powers. Like one of them was Austin Powers and one of them was the bad guy that attacks him. So they were fighting it out. And I think he said the word frickin' 73 times in Channel 9 on camera. It was really funny, so I just said it twice, so forgive me. One of the funniest presentations that I've ever seen. Now, some of the code that I'm going to show you today came out of that presentation. If you want to know more about Andy and this kind of stuff that he does, he's Andy Barweb, Andy Bearweb, I guess, on Twitter. So that's where you can get in touch with Andy. Andy has done a whole bunch of this stuff just for fun, like me. He's also done a whole bunch of SignalR stuff. So if you dig those two topics, I just want to give you another resource where you can find him. All right, now, last thing I'll show you are a couple more links, and I'm going to show you. This is the .NET Gadgeteer site. You go to netmf.com/gadgeteer, and there's all kinds of cool projects that you can do. There's all kinds of different pictures of projects that people have built. SDKs that you can download, forums you can read, all kinds of great stuff that you can do with the .NET Gadgeteer. The .NET Gadgeteer is basically a pluggable system, and I want to pull up a camera here and show you what it looks like. My 5-year-old son, when he was 4, he could do this. He could also put pins into a Netduino. So I just want to point out, if I can do it and he can do it, believe me, you can do it. It's not that hard. The hardest part is just understanding the way the voltage is going to run. Okay, so just want to point out that it's not that difficult, it's not that intimidating. And the last one, there's the Netduino smartwatch. Now this is that's actually netduino.com, and you can find stuff for the Netduino, and then the Pix that they've just got coming out. They've got a Netduino Mini, and then there's the smartwatch. Nice thing about that smartwatch, like I said, it was a Kickstarter project. Let me show you this. This is really neat. They put this out and they needed 100 grand. They needed 100 grand. They had 6 times that by the end of the weekend. Okay? They have far exceeded their expectations, and I think that the watch will actually come out sometime between November and January. There's still room in the Kickstarter. I don't work for them. They're nice guys. I've met their founder once or twice. Really awesome guy named Chris. I would recommend that you take a look at that if you're into the whole smartwatch thing. He kind of has this attitude that he wants it to be like nice looking and functional. He's a really stylish guy. I mean, you be the judge. If you think it's nice looking, then that's great. Support it. But it's not as big as the big Samsung one that came out. And I actually saw the other day that Nissan has one that'll talk to your car. Why do I mention that? It's obviously one of the next waves of technology. Smartwatches, pretty cool. We're done with smartphones. We're moving into watch land. All right, now there's a Windows Azure portal. You've probably seen that a couple times this week. I'm just showing that to you because I've got some stuff running up there that we're going to be hitting directly from our device. Now let's make it interesting. How do you get started with .NET Gadgeteer programming? Well, give me a simple project that I can do. So here's the first demo. A real-time temperature and humidity sensor with the Gadgeteer, SignalR, and Web API. Now, how many of you saw my SignalR demo where I basically hit a Web API and then I turn around and just fire it up with SignalR? Okay, this is sort of like that. This is that idea, but it's going to be useful, sort of, kind of. Now what I'll do next is I'm going to flip over here to Studio. Look at that. Does it get easier than that? Let's say I want to add a camera to this. This could blow up my demo, but hey, that's what we're here for. Let's say I want to add a camera. I would basically find my camera, probably just past it. Camera. I'm going to drag this guy over. It's going to drop it onto the designer surface. Dope. Oh, I don't know where to put it. I don't know where to connect it. It's going to be so hard. Oh, maybe if I click this. Oh, I got to put it right there. I'm ready. So I've just connected a camera. Now, I would go down to this little guy. I'm going to undo that before we blow ourselves up here. I want to go down to this little guy right here. And you'll see, if you take a peek at that circuit that I built over here, Windows. Let me get rid of this guy. So there's our circuit. You see that it looks very similar in nature, but flipped to the circuit that I've got built right here. So there's my network card right here. This is my USB controller. This is what you plug into the computer and then you plug into the device. This is the brain. You have to be kind of careful with it. This right here is a temperature and humidity sensor, I think. Yeah. The other day I hooked up the accelerometer and the world caved in on me. Okay. So, and I'm just going to use this little IPvo presenter. I think it's called a Ziggy. If you ever want to do presentations like this thing's pretty neat. It's about $60. There's an Epson one that's probably $1,000, but I'm cheap. So I'm using the Ziggy. So now what I'm going to do is I'm going to take my handy dandy little USB cord right here. Normal little USB, and what's that plugged into? What is that plugged into? Oh, that's plugged into the camera. Can't really disconnect that. Let's get brave. All right, now I'm going to plug this in right here. You should see that it'll light up. All right, so I've got some lights going off right here. Now, there's a really awesome tool that you get when you install the .NET Micro Framework. It's called MF Deploy. Feel free to make jokes. I'm going to open that guy up, and you'll see right here, MF Deploy. And if I go ahead and I click USB right there, you'll see that that'll light up. Now, if I had my NetDuino and my Gadgeteer hooked up, you would see two items in that drop-down. MF Deploy knows when you've connected something that's running the tiny CLR. And it reaches out and it makes a connection to it. I want to ping this. It may not respond. Yeah, it responded. So that's telling me, hey, it's working, everything is money. All right, so you see that tiny CLR right there? Let me zoom in on it. There we go. So pinging tiny CLR. Now, you can also do things like install an image onto it. I could erase it if I want to. I won't do that. If I click browse right here, it's going to try to find a certificate that I can basically embed onto the guy. So I do want to point out that you could use MF Deploy to basically troubleshoot and make sure your device is responding. Okay, so that's kind of valuable. Now, what I'm going to do next is I'm going to go back over to the Windows Azure portal, and I'm going to click on this temperature and humidity API guy, and I'm going to pop up this little page right here. It's just going to show you two gauges. And this is the cool part. I'm going to go back in the studio now, and I'm actually going to hit Start. Before I do, I'm going to put a breakpoint right here. I'm running out of screen real estate, so forgive me. And this is the part that everybody that is into Schadenfreude will be really excited to see. All right, it's going to query it. It's going to say, hey, are you cool? Are you running the tiny CLR? Can you respond to me? Is everything going to work? Et cetera, et cetera. And the cool thing about .NET MF and the Visual Studio tools and the tiny CLR is that they work together to give you the ability to debug your code on the device. You can actually run code on the device and step through it a piece at a time. Now remember one very important thing. Very low memory footprint, very small processor. If you try to drag something into your watch window, you can kind of go get a coffee, drink it, get another one, and it might have popped up in that watch window. So it does take a little bit of time for your stuff to pop up. You have to be very patient. Not only do you have to be patient, you have to be tolerant because, like I said, the failure rate is pretty high. So sometimes when the stuff runs, it won't actually work. Now you see it says, I want you to turn yellow. That's kind of yellow, right? The colors aren't exactly precise. But what it's going to do is it's going to turn yellow and show me, oh, I'm not showing you. Turn yellow. All right, so that's the thing actually turning yellow. Now what I'm going to do is I'm going to just go ahead and let it run here. Too many windows open. So that's going to run, and you'll see right here it'll start to send its signals. It's bouncing messages up to it. Oh, look at that. Now check this out. Did it work? Awesome. Is that groovy? I can work SignalR in anywhere, man, I'm telling you. It's the awesomest technology ever. That and Azure. All right. So you kind of getting some ideas here? I want to monitor my kid's temperature in his room because our heating unit really only makes the living room warm. My kid's room's always cold. Drop one of these in his room. Now you can control everything individually. I've seen some of these running in refrigerators. Why? Because you can. All right, now you see that I'm debugging it and I'm sending the messages up here. As it cools off, you'll probably see the sensors kind of start to go back down. So that's a case where I'm actually issuing commands up to a web API, and I know you want to see the code, so I'll pull that up real quick. You've already seen this. But in my web API, I've got my sensor controller, which is actually my API controller, and it's pretty simple. I'm just going to throw it an object, or a pair of objects, temperature and humidity, and then I'm going to turn around and do what you've seen yesterday. I'm just going to call my SignalR guy, reading received. And in my JavaScript code, somewhere, index, you've probably already seen this if you were in the JQ guide. Now I'm actually using JQ plot for my charting to show you those gauges. Let me minimize this guy. And if I scroll down here into my code, you'll see that I'm just rendering my JQ plot. That's not mine. I'm basically giving it a couple of gauges. And then right here, just like you saw me do yesterday a couple of times, I'm going to make a connection back to SignalR. And whenever I get an updated reading, I'm going to replot everything on the chart. So in a couple lines of code, I've given you the ability to connect a device up to Windows Azure through an API and to have a live monitor with gauges that are going to update as the thing gets messages directly from the device. Okay, groovy? You guys like that? Now, this is not devices and APIs talk. This is devices and Azure talk. We have a lot of capability inside of Windows Azure to do storage. We have a lot of different things that we can store. We can store blobs. We can store information in tables. And what I'm going to show you now is actually another kind of an API call that we could do where I can actually send messages up in binary format. I can post data up to the server and save it into a Windows Azure blob and then display it on the screen, again using SignalR. You can work it in anywhere. I told you that. All right, so I'm going to close this guy down. And I'm going to go right over here. Hopefully I've uploaded it. There's my image capture guy. And I'm going to click Browse. I cannot remember the actual URL, so I may have to open up the code and figure out what page I'm going to direct it to. I actually even deployed it yet, so that's good. Go ahead and do that. So I want to open up this security camera guy real quick. Before I blow the device up, I'm going to disconnect it. So you'll see that it's actually, the lights are going to go off as soon as I disconnect it from USB because it's powered by USB. Maybe, or sorry for those of you that have motion sickness. All right, so there's that. Now what I'm going to do is I'm going to go into my project here, and I'm going to open up my website because I'm going to need to deploy it. I haven't actually deployed it yet. Okay, it looks like I might be missing something here. I'll just upload it, whatever. You deploy that. I'm going to publish it out. I'm just going to publish this just like you've seen us do with a couple different websites already. I'm going to select my image capture guy real quick. And what I've got in my web config is basically a connection string back to my Windows Azure Storage account, which I've got open right here inside of the Azure Management Studio, originally by Sarah Brada, and I think now they're owned by Redgate. Could be wrong on that. Is that going to let me pull it in? Image capture. It's cool. Going to run that guy. I thought I had a client where we could actually watch the image update, but I don't think I have that in this solution anymore. I've tweaked this quite a few times. Now, while that's publishing, what I'll do next is I'm going to open up, there we go. It's good stuff. Yeah, we'll just see the images pop in. I want to open this guy up, and you'll see that I kind of have a new board structure. I've got my Ethernet. Now, Ethernet's plugged into 7, and on this guy, Ethernet is indeed plugged into 7. I have nothing plugged into 11, so I'm going to unplug this guy, and I'm going to unplug this guy. And now I've got a camera. A little bitty camera. It does not take great pictures. I mean, if you have a great model. But I've been running through the rain, and I'm up here with a lot of hot devices, so I'm not going to try to take a picture of myself. I'd rather not be immortalized. Of course, that guy back there is streaming me out to hundreds of people right now, so there's that. Now, I've gone ahead and I've plugged up that camera. You'll see that just like before, it's exactly the same circuit. I've got the camera plugged into one guy. It's backwards. So there's my camera plugged in right here. My network cable is plugged in over here, and then obviously I've got the USB port still plugged in so that I can communicate with it. Now, I want to go over here to this guy, and I want to show you my blob containers. I don't have any blob containers out there except for the ones that I'm using for my deployment stuff and for my analytics coming in from my Windows Azure services. And in my web config file, I've got my connection string that goes over to my storage account right here. And I've just set up a pretty simple storage account to use in these presentations. Now, the other thing that I've got in this guy right here, you'll see that I've added in a handler, an HTTP handler. This is like old school ASP.NET stuff. I'm not using Web API for this upload. You could do that, and I've done it before, but this is just, brass knuckles, dirty, old school ASP. And then I've got my capture service guy, which you'll see there. And all I'm going to do is I'm going to new up a blob client and a blob container. And whenever this guy gets a request, I'll look right here. Whenever it gets a request, it's going to kind of assume that it's a byte array. If it's get, I'm going to bail because I can't upload stuff through get. If it's post, I'm going to basically look at the collection of files that I'm getting my HTTP request. I'm going to look at the file name for that guy to create a blob. Then I'm going to upload the blob, write that blob into, I'm going to basically get back the URL for that blob, and that URL is going to be returned back to the client. The reason I'm going to do that is so I can actually show you the image. And I could swear that I have this, I have another project somewhere. Oh, monitoring device, console client, image capture web. No, I guess I don't. I thought I had another guy in here that would actually show you everything as the images were coming in, but maybe I 86 that. So what I'm going to do now is I want to plug this guy back in, and you'll see that I've got the monitoring device set as my runner. And let me show you the code for this because it's pretty neat. I've already told you how this stuff is really, really low level. But what's awesome about the NetMF programming structure and all the different providers for like Gadgeteer and NetDuino is that they actually give you event-driven approaches to writing your code. So I'm going to show you kind of what that code would look like. So I've got a timer here. Now what they say with the Gadgeteer, they say please don't do a while loop. Most of the time when you're going to do low-level programming, you set up a while true, and it just spins. The Gadgeteer has a little bit of a higher order programming structure. You can actually set up a timer, and when the timer fires, you can do stuff. All right? So just like always, I'm going to do program started. I'm going to let you know. And this is kind of neat. So I've got this camera guy that I've attached, and it's got an event called picture captured. And I'm going to handle the picture captured event using an event handler. If I scroll down here to show you what that looks like, you see I'm just going to write picture taken, then I'm going to get the data, and the data lives on this event handler right here, picture, or event args, if you will. Then I'm going to create a post request. Oh, do you see this? Come on, laugh. You get it? To the cloud? Do you guys not have those commercials over here? Okay, never mind. Must be an American thing. There was this line of commercials where they go, to the cloud, all the time. All right, so I'm going to attach a header to it, and the header is going to be the file name, and I'm basically creating that file name directly on the device. I'm just going to say, like a timestamp for all intents and purposes. And then I'm going to say, here's another event. Once I get the response back from the server, I want to do something. And I'm going to use an event handler to do that. So what I'm going to do right here is response code, and I'm going to get back whatever the server responds with. Now remember what the server responds with. It gets the URI of the blob. So I upload a blob, and Windows Azure Blob Storage is going to tell me a URL that I can use to pull that blob out. I'm going to mark that blob as public. So after I upload it, I can just take that URL, drop it into a browser, and bam. Those of you that are addicted to SignalR like me are probably getting an idea here. We'll just update it live on your SignalR guy. Yeah, I could have done that. I think I may have in one incantation of this guy. And then what I do is whenever the timer ticks, this is very important. You get into this stuff, whenever you handle your timer tick, stop your timer. Because it's going to tick again and you're going to have stack. Okay? It's going to get nasty. It's going to get real nasty. Because you'll still be processing the last timer tick when it ticks again and you come back through. What do you think it's going to do then? Memory overflow. Buffer overrun. Your device is going to go, no. It's not going to be a good day. So I just want to point that out. You want to stop your timer, do your processing, and then go back into it. These are really small guys. And in my timer tick, I'm just going to take a picture. So whenever I get into the timer tick, take a picture. Whenever the picture gets taken, upload it. Whenever the upload completes, handle the upload, start the timer again. You figure that out? Kind of see that progression? You don't want to do this just, you don't want to do this synchronously. If you do it, ugly things will occur. So I just want to stress that. I want to plug this guy in again, and I may need to reset it. All right. And now I'm going to just go ahead and hit run here. Wish me luck on this one. What I'm going to do is I'm just going to attach my debugger, look at the output. All right. So far, those of you that were in here to see fire and brimstone are not happy. Looks like things may work. I would have to say that. And it should start taking pictures pretty quickly. So what I'm going to do, I'm just going to get really ugly here. I'm going to lift this up, and I'm going to take some pictures of the crowd, maybe. It's a little dark, so the picture may be a little dark. If it is, I'll go ahead and expose myself facially. Nice, it's deployed. You'll see that it's going to give you all that debugging information so that you know if your deployment's actually going to work. If the deployment wasn't going to work, it would have already told us, it's not going to happen. All right, so once that wires up, we should start taking pictures unless I've plugged it into the wrong pin. Again, I apologize for the wait time, but that is part of the deal. When you're doing MF coding, you've got to wait because the device is kind of low footprint. Hopefully this will party. Maybe. Oh, maybe. Looks like it's going. We can go over here to MF deploy and ping it. Okay, that's a good sign. Let me make sure that I'm deploying to the right guy. Okay. And what you'll see there is that I double-clicked on my Gadgeteer project, and I went over to the Properties tab, and I looked at .NET Micro Framework, and you've got a couple of different deployment options there. I can select my transport as USB. If I've got it hooked up over serial, I could do a serial deployment there. There are a couple different emulators that you can use. I've just got my device plugged in, so I'm going to go ahead and select the USB guy. Looks like this deployment may have tanked. Par for the course. That's right, that's right. Okay, let's stop the deployment. Dang, it was all optimistic. I had to say that it worked. All right, now I want to ping it again. If it comes back, then that's interesting. So that's coming back, so I'm going to reset it. You see, as soon as I unplug the USB, it's going to drop out. It's going to drop out of that list, so it knows that it doesn't have a device that it can communicate with. I'm going to plug it back in, and it's going to wake back up again. See that I do have Gadgeteer selected here. So we're good to go. I'm just going to try this one more time. Again, if you get into this stuff, if you buy yourself one of these guys, you just have to live with this. It's just part of the pain. Anybody think you might want to party on this stuff? You think this looks interesting? You might want to buy one? Who thinks it's really expensive? Okay, cool. The NetDuino is between 30 and 60 US, depending on which version of it you get. I've got the Plus. That's about 60. This kit that you see right here, it comes with a bunch of stuff, including like a 4-inch square touchscreen LED. Okay, that's $250 US. So you can get started for not a whole lot. If you play with stuff, you can get started for not a picture taken. See if it uploaded it. Network gods beware. Yes. So I'm going to go over here. There's our blob container. Image capture archive. Let me double click this guy. All right, here, smile, wave. I obviously probably can't do video on this. I mean, you could, but your life would suck. It wouldn't be fun. I'd love to get together with Meng Fei and do something with this and her stuff. Man, that would be cool, huh? Let me open this. Oh. Same one. Open this. Same one. You look great. All right. So that's that. But what you can see is that it's actually uploading this. So I could copy these URLs out right here. Let me get the last one we post just for giggles. I'm going to get this guy out. Now I've marked it as public, so I could just copy and paste it here. There. We got a board. That's great. All right. So that's actually posting binary data over the wire that we just recorded directly from this guy. Now, think of the possibilities. If you could do inbound communication to your device, you could set this up so that you could take pictures all over your house if you want to. You don't have to go out and spend thousands of dollars on your own home security monitor. Instead, you could just spend thousands of hours building it. But hey, one's fun and one's easy, so there's that. All right. So that's a security monitor that we built with Signal. I guess I should take the SignalR part out since I got rid of that part of the demo. But using Web API, or no, excuse me, using a handler, pardon me. Now, I've shown you how you can basically post data up to the cloud and save it inside of a blob. That's pretty cool. But what if you want to access the Windows Azure APIs directly? So one of the things that I've talked about is it's basically a series of REST APIs. You can pretty much do whatever you want with those APIs. You have to speak XML or JSON on the wire. So what I'm going to show you real quick is some code that actually Andy wrote for his demo that I stole with permission. I'm going to show you this with the Gadgeteer, and then I'm going to show you with the Arduino if we have time. So what I've got here is I've got this project called Azure Micro Helpers. And this project basically has stuff in it for queuing, for blob storage, for working with Windows Azure Tables, which is what we're going to do in this demo, or pair of demos. And then I've also got this little class right here that my good networking friend helped me build. When I got here the other day, he said, hey, I've already set up a bunch of IPs for you. I've given you your DNS server, and I've given you your gateway. So what I did was I added this class to this project, and I just call this class, and I set my IP address of my machine. These devices do support DHCP, and they do support dynamic DNS, but you know, why do that if you don't have to? So he gave me two static IPs that I could use, one for my Arduino, one for my Gadgeteer. So I'm just flipping those back and forth. I point this out because it's low-level programming, so sometimes network stuff can be bad. It can be hard. This is the code that will basically give you the bare metal just running right on top of the network card. And you'll see this guy right here. I'm going to get the network time. I'll go into that method and show you what that looks like real quickly. It's part of Andy's code. I'm actually going to hit time.windows.com to get back my time. Why would I want to do that? Because I want to put the time on the device so that when I try to make a call to Azure, which says, hey, what time do you have? Because I don't have that time. It looks like we're out of sync. The time will be a little bit more in sync. Okay? And that way the communication can actually happen. So the first thing I do is I get my IP address. I wire everything up to my network. I ping timewindows.com, I get my time, I tell the device what time it is, I set its time explicitly, and then I can make conversations back and forth to Azure. It's just a kind of a safety net for us. Make sure we're not throwing at really bad messages or out-of-date messages. All right, so there's kind of my utility class here. Now what I want to show you next is, if I open up this table client guy right here, I'm going to shrink everything down. Now, everything in Windows Azure from your perspective is just a series of REST APIs. So you can throw it XML, throw it JSON, get back XML, get back JSON, and everything will work. All right, so what I'm going to show you real quickly is I've got this table client. I new up a table client, and I pass it my account name and my account key. I'm going to create a table. So in this case, what Andy's done is he's actually just hard-coded the XML. He just took this XML and dropped it into his file. And I think that he's using kind of an older version of the REST APIs from Windows Azure, but the nice thing is we don't fully deprecate those signatures. We know you might write code that's going to look like this, and once we add a new version, as long as you tell us what the version number is that you're expecting to hit, as long as it's not in the future, and we haven't done it yet, we're just going to maintain it. It's going to work for you. So this is just an XML structure that you can hit. And what I want to show you is that if you go out to, let me just bang this real quick, Windows Azure Management REST APIs, you'll see right here, on the MSDN, we have a huge, this is probably the service management. Yeah, this is the service management API. But we also have a normal API that you can use to save data back and forth to tables. This is the Service Management API. I'm currently using this with my team to give you the ability to do things like create accounts, to create hosted services on the wire using an SDK. That's going to be coming, but all this stuff basically has an API, and as long as you throw it XML, you're good. So what he does is he creates a table. That's a table request guy, and he's actually got a hard-coded method, add table entity for temperature, and what he does is he passes it like temperature and the country, and what that'll do is it'll actually put a record into a Windows Azure table just with that tick of data. Okay, but what you have to do is you have to basically wire up all the XML and send it over the wire. You could do this in any code you wanted to, and if you look deep in our SDK code, this is probably similar to what it's going to do. It's going to build your payload and ship your payload up, get a payload back, parse it, and party. All right? So that's basically how that works. Nice thing about it is we've put this into a tiny little utility class. So inside of your code, I've got this scenario here. I can basically set a couple of parameters like my account key and my account name. I can new up my scenario. I'll new up an instance of that table client. I'll create a table here, netmf data, and then I'll just save the temperature. And this guy I would actually just call the table client add table entity for temperature. Now, Andy and I have talked about refactoring this code somewhat so that instead of only being able to do one thing, save a piece of data, we would have like an interface here that you could say, I want you to build the XML payload on your own, take the data that is in your object and just serialize it and send it up the wire. We haven't gotten into that yet, haven't been able to do it yet, but just kind of the general idea. You can just make those requests back and forth. Now, I've got this code written for the NetDuino, and I've also got this code written for the Gadgeteer. Since I've got the Gadgeteer plugged in and we're running a little low on time, I'm just going to run it from the Gadgeteer. But in my NetDuino project, I've actually referenced those two, the micro helper and that scenario guy, and I'm just calling the code exactly the same way. Okay, so here's my storage account. You'll see that I have one table, which is my logs. I don't have a .NET-MF table yet. I'm going to plug in my device one more time. I'll just leave all that stuff plugged in. Now, the only thing I'm really going to use this time is going to be the network card. I'm not going to be reading from any sensors. I'm just going to be basically posting 42, 42, 42, just to kind of show you that it'll work. Now, if I go over here to program, let's do a debug here. I'm going to hit F5. Hopefully everything will party. We may have another crash like we did before. Oh, it's so hot up here. All right. So that's going to deploy the assemblies to the device, get everything wired up. That's going to make, I've got a breakpoint set, so we're going to stop it. But what will first happen is that I'm going to set up my network, then I'm going to new up my scenario, then I'm going to create that table out in Windows Azure. After that table's been created, I'm going to start sending data up to it. And I'm going to do that using my timer tick event right here. And I think what I'm doing in this, guys, I'm actually creating the table. Yeah, I create the table here. Now this call, what it'll do is it'll reach out and it'll say, hey, if you don't already have that table, I want you to create it for me. I don't have it, so it should create it. And what we'll probably see in the debugger is it'll say creating table, creating table, creating table. I'm not really creating it each time. I'm just verifying that it's there, and if it's not there, I am creating it. It's exited, so yeah, it has exited. So let me do this. Let me ping it, make sure it's alive. You starting to pick up on a trend here? It's very sensitive code. So that's got to be disconnected. Make sure that all my ports are exactly the same in this implementation, or my circuit rather. Yep, 7 and 1. Actually disconnect the additional one here. I don't need my camera anymore, so I'll put that over there. Don't do that when it's plugged in. Bad things can come of that. I'm just going to hit F5 one more time and hopefully it'll find the device. If not, we're going to move on. But this is just an example of how you can actually use the Windows Azure APIs directly from something as low level as a 1 meg device to issue those REST calls back and forth to Windows Azure to save data up to it. What I've done up to now is I've done that through ASP.NET code, just using like a web API or that handler. Okay. Wish me luck. Oh, come on. There we go. Attaching, waiting. Found it. Good. We're good here. This is going to work. loading the assemblies. There we go. So now it's going to spin up. There's our ugly dialog. That always happens because it has to just push all the assemblies down. And you'll see that it even tells us what the board is. It tells us that it's the Fez Spider. There we go. Hit F10 here. Set up my network. There we go. New up the scenario. That'll shoot out and create the table. There we go. Save the temperature. We go back into my guy right here. Refresh our table. There's our data. Open it. There's our data. So you'll see as it's posting data up, we're actually getting stuff out here. Now, why would I show you this? There's this awesome site out there on the internet. I'm trying to remember what it's called. Shoot. I cannot remember what it is, but it's basically a site that you can use devices like this. I'll think of it by the end of the conversation. It's like an Internet of Things site. And I've always wondered how this site can get so much data into it. That's going to rock me for the rest of the talk. I started thinking about, well, Azure tables are dynamic. I can basically change the schema of an Azure table depending on the object that I want to throw it. So imagine all that storage space. Imagine all the devices out there that you can actually communicate up to it with. I'll remember the name of the site here in a minute. But if I connected this with my NetDuino, I'm actually going to be getting the NetDuino over here for my partition key. What will happen is every single device, if you get the MAC address and you use the MAC address for your partition key, now your device has its own partition in that table account. Somebody else's device has that table in its partition account. And if you were in Luke and I's talk yesterday, or if you've messed with Azure Storage, it's really inexpensive, especially when you're doing tables. These are really just strings in a database somewhere. Not a database, but in a flat storage. So what you can do is you can just basically store unlimited data. Imagine all the devices out there that you could actually send the data up and communicate with Windows Azure. Or if you've got the unlimited blob storage, you can post all that stuff up as well. I've always wondered, before I saw Andy do his demo, how I'd be able to make smaller devices do this stuff. Now I know. When I saw Andy's talk, I said, I've got to steal that and do it at TechEd. He said, okay, cool. Just make sure you give me some credit. So there's that. Now, again, I've got a piece of code that I can do exactly the same with NetDuino. The results are going to be exactly the same. It's going to be a table, but it's going to say NetDuino 42 NZ. All right. Moving right along. Agent Watch SDK possibilities. This is going to be kind of a silly demo because it's really just the SDK. I don't have the watch yet. Need to kickstart that. And what I want to do is I want to double click this guy, and Hanselman has a pretty cool blog post on this. Code isn't really all that difficult, but basically every one of these guys is going to give you a series of fonts that you can use whenever you want to draw text on the screen. And I'm going to new up that font from my resources. I'm just going to draw it on the screen, and I'm going to display a message directly onto the watch. I'm going to say hello world. Then once it wires up, I'm going to make a call out. Once I push a button rather, I'm going to make a call out to a web API running up in Windows Azure. And the reason I'm going to do that is I'm actually going to get the time from the server. I figure it's a watch. I'll show you the time based on the cloud. So I'm just going to hit F5 here. Kind of a silly demo, but there are a couple of good stuff coming with this. There's actually a source code project that I've got that I downloaded from Codeplex that's called Agent Contrib, where they're basically stewing over how to do all this stuff. Now, if you were actually coding against your watch, this is going to be exactly the same thing. You're actually going to be able to push this button, and the code's going to run. Unfortunately, nobody has the watch yet. So I'm going to hit that, getting the server time. It's going to reach out to Azure, get back the time from the server, and then it's going to actually show you the time right here on the guy. If this is the one demo that blows up, there we go, 947. But that's 947 wherever Azure's running. Okay, put it that way. All right. Whichever guy that I've hit, I think I'm hitting West US, so that might not be right. It might be a UTC. But does that give you some ideas? Imagine writing an application to run on your watch. Anybody got a Fitbit? You could write the code to basically do the same thing on your watch, and it could basically sync up to Windows Azure, post your stuff, and you could gamify it based on your watch. There's a MVP over in Sweden who's actually written his own custom watch face for this guy, and he does some stuff with Azure. And here's this Agent Contrib guy. I'm going to open that up real quick, and most of this code is still prototypical, but I just want to show it to you to give you some ideas of what might be possible whenever this is all done. So I open up this Agent Contrib. Face. You could actually build your own custom watch faces. Geolocation. Get some ideas there. But let me show you that this code is definitely prototypical. He's got an eye position guy right here. You can see where he lives. Okay? It doesn't really get the GPS. What this guy's doing is he's trying to push the Agent Watch SDK further and further by coming up with these mock signature classes that you can begin to code against and contribute to. He's basically trying to settle the argument of how these APIs are going to look on the watch. And he sent these over to Secret Labs, and they're like, oh, that looks pretty cool. We might have to think about that. You've got hardware integration. There's your accelerometer. I can actually hook into the accelerometer of the watch and build my own little Fitbit. Sync it up to Azure. Getting some ideas there? Think it's good stuff? I don't know if I can actually, let me do this. I'll set this as a startup. I don't know if this will run. I've never actually tried it. I'm just going to hit F5 here. And this should just show me a custom face, maybe. There we go. So that's like somebody that's built their own watch face. There's like two ways that you can program against the agent. You can build a face or you can build an app that'll run on the device. Pretty cool. I've seen the Samsung stuff that's been coming out recently. Those watches look pretty cool too. I don't know what their battery life is like though. I hear their battery life is not that impressive. Anybody picked up a smartwatch yet?
How does it communicate with the network?
It's very interesting what it does. The Agent Watch, I can't speak to the Samsung. The question was, how does it communicate with the interwebs? Is that your question, interwebs? Okay. What it does is it creates a connection to your phone. So it communicates to the web through your phone. So it basically hooks up to your cell connection or your data connection, and your phone will do the stuff, and then you party. What's nice is it'll actually do things like it'll jack into your calendar. So whenever you have an appointment reminder, you don't have to grab your phone. I mean, God, that's so exhausting to pick up my phone. So whenever you're getting ready to be late, you're like, it'll just let you know. Kind of like your Fitbit when you hit 10,000 steps. So there's all kinds of possibilities with that. The Secret Labs guys, they're the ones that created the Kickstarter for the Agent Watch. They've actually got connectivity to iOS, Android, and the Windows Phone. So they're actually just got parity across all that stuff. So that's pretty exciting. So that's the Agent Watch SDK possibilities with Windows Azure. Imagine all the stuff that you could do. Okay. Now the network guy taught me into this one. All right. This is cloud-to-device communication using Windows Azure. I have a friend in Charlotte, North Carolina, US. He's the guy that told me this is how you get over your fear of electricity. Build robots that'll shock you to death. He actually built an entire home watering system that waters his lawn using Windows Azure and 11 Netduino. And he did something really smart. He decided to have the .NET user group meeting at his house one night so we could play with Netduinos. You know what he was doing? He was giving each person an assignment for 3 hours, and at the end of it he was like, mine! And he just took it all. Okay? Okay? I think he actually bought all the devices, so he basically created slaves out of us for an evening. But what his thing does, which is really cool, most people, they would just stick the little humidity sensor in the ground. Thingsspeak.com. Sorry, that's the website I was trying to think of. Thingsspeak.com. Things like little devices. You can basically set up an account and post stuff up to it. It's the API, and you can watch charts fly for it. But what Mike did, Mike Lennon, what Mike did was he actually went one step further. He said, I could just stick a humidity sensor in the ground, and whenever the ground gets dry, I water it. But the problem with that scenario is that I don't know when it's going to rain. Like if I just stick it in the ground whenever it gets dry and it waters it and then it rains, all my grass is going to die. It kind of defeats the purpose. So he went one step further. He has an application running in Windows Azure, and every couple of minutes it goes out and it pings a weather service to figure out when it's going to rain. Okay? So he knows what the probability of rain is. Now let's say his lawn watering system kicks off every morning at 7 a.m. and the forecast says it's going to rain that day. His thing would send a message down to his house, to his device, and say, hey, it's going to rain today, don't turn on. So he saves himself the money on the watering. Now, the CTO of the company that I worked for at the time saw that idea, and he goes, I've got one of my own. He wired in a Netduino with a Bluetooth receiver to his garage, okay, because he only had one garage door opener. He's also got a Windows phone. So then he put up a service on his server somewhere. He didn't run it in Azure, but he put a service up on his server so that when he pulled up in front of his house, he could open up his little Windows phone app and say, open, and it would open the garage. Problem was, he was showing it to people at work. His wife calls him, and she says, would you stop opening the garage door? All right? So he was all excited. He also built he has a swimming pool, and he's got a water cannon on the back of that swimming pool. And what he did was he hooked it up to an Arduino, and he could control it through his Windows phone. He would actually do all this. So these possibilities are endless. Website LED controller. I'm going to open this guy up. And this is the last demo that I'm going to show you today. Hopefully you've enjoyed it up to now. Microhost. Open up both my guys right here. All right, now what this is going to do, this is kind of neat. I'm going to look at my circuit and make sure everything is the way it should be. All right, I don't need that. That's my LED. So I want to plug in my LED right to 14. Make sure everything else is as it should be. Yep. So this is a multicolor LED. That's the one that turned kind of yellow earlier. I'm going to put this down here so you can see the LED. Blah, blah, blah. Maybe. I have to pin it down. All right. I promise we'll end on time. So there's my design. Now what I'm going to do inside of this guy is I'm actually going to run a web server right there. I'm going to run a web server on that device. Okay? I'm going to get the IP of this guy, and I'm going to start my local web server, and I'm going to run it on port 80. Then I'm going to set up 2 web events. Remember when I talked about Owen, if you were in the talk yesterday, where it's just really simple HTTP? I'm going to tell you where I'm going to listen, and when you hit me, I want to do one thing, just one thing. So I've got 2 web events. One is red, one is green. In Mike's case, this would be, should I water or not? Okay, I'm just going to show you with the blinkies because they travel from the states a lot better than does an entire watering system. Get the point? Going through security with this stuff? Challenging. Okay, so there's this guy. So I'm just going to open up a web server on this device and start listening for connections on port 80. Then I've got this code, which is going to be a site that's going to be running up in Windows Azure. Whenever I hit my API controller from my web client, I'm going to read in 2 things. I'm going to be real brave and show you the IP address so you can come and hack me if you want to. Crash my device. Feel free. I'm going to scroll down right here, and I've got these 2 guys configured. This is the IP address and port that you could hit in the firewall that will come right here. I wanted to actually have the network gentleman come up and pull up the firewall right here so you can see the packets flying, but you can see that it's been converted into a stand. So we won't be doing that today. But basically, he's opened up a port in the firewall at 9001 so that 9001 will hit 80 on this device. I don't need to run that code because I've already deployed it, so I'm going to close this guy down right here. I'm going to go over to this guy. There's my LED controller site. I'm going to hit Browse. Okay? Yes. We're going to send messages to the device from the cloud. From the cloud. Hit F5 here. Am I plugged in? I probably need to pull up the camera. I probably need to, this is the LED right here. We'll see that changing here in a second if all goes well. We might have to reboot it one more time. We've got 4 minutes, come on. Come on. Not feeling good about this. Okay. All right. Waiting. Oh, 3 minutes. Come on, reboot. Says it's rebooting. Means I probably had code on it that was running that freaked out just a minute ago when I disconnected everything. Maybe. This is kind of the icing demo. This needs to work, guys. Shoot. If you need to run to your next session and we hit 10, feel free to leave. I will not be offended. The device is not responding very effectively for me right now. Okay, it's frozen, so I'm going to reboot it real quick. And again, this is not a testament to how bad these devices are. It's just that, you know, it's got a meg footprint. What are you going to do? Okay, we'll plug it in one more time. Let it reboot. Ping it one more time. Oh. I wonder if it deployed. And that's the other thing. Sometimes it'll deploy and the debugger will look like it didn't. And then the code will just start working. So I just do want to point out that, you know, it is an imperfect science. It's getting more and more perfect as each release comes out. There we go. We're wired up. I'm going to shrink this guy down real quick. I'm going to get rid of this. Now the device is going to respond with whatever it does. Okay, so the web API is actually going to get a response back from the web server that happens to be running right here. You make sure that it's all dialed in. Okay, there we go. Program is started. This is the site running out in Windows Azure. There's the URL. Okay, shrink this back down. Awesome. All right, now again, I want to give the networking gentleman a round of applause. That was his inspiration. He told me, I told him I have this inbound demo that I want to do, but I'm scared to do it because I'm afraid the networking cops are going to, you know, bite me. And he goes, "Don't be a pansy, do it." So luckily, he actually works with microcontrollers, so he knew this pain, and he inspired me to do this. So here are a couple of additional resources. Pete Brown is the Blinky Lights evangelist. Pete Brown knows all this stuff and more. He actually connects his little devices to his MIDI controllers, and he makes musical instruments and all kinds of crazy stuff. The GHI forum, if you're messing with any of their devices, such as the Gadgeteer, that's the best place to go. A colleague of mine in Virginia named G. Andrew Duthie, he works pretty much with Pete Brown on a lot of the Gadgeteer and Netduino stuff. They like to play with it. The Netduino forums are absolutely fantastic if you get into the Netduino stuff, and I think they have a specialized forum specifically for the Agent Watch if you decide that you want to party on that. There's the Agent Watch official site. Hanselman got a really early sneak peek at that SDK, so he wrote a pretty cool blog post on how to do it. And then there's an MVP out there in Sweden. I cannot remember his URL right now, but he's got one where he actually builds like an equalizer readout. So it's basically a face that just beep, 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 beep. So I just want to point out that there's all kinds of stuff that you can do. Just because Windows Azure is huge and you can do a bunch of stuff and the SDK is large, it doesn't mean that you can't run it on a machine that has a 1 meg footprint. As long as you can speak HTTP, you can speak Azure. Thank you so much for coming. Had a great time.